There we go. Redo. You gotta redo the whole thing now. Everybody slow. No. Alright. I'll give about another minute. And then I'll pick somebody random. Help me out. All right, let's look at our first one. Ashlyn, let's look at this table right here. Is this linear? Yeah. Is it linear? Yes or no? Because? Yeah. So what does this y change by? From -1 to -8. How much does that change by? Yep, it goes down 7, right? How about on the next one? How much did it change by? Oh, what'd you do? I guess you got lucky and you guessed then. All right, let's see. How about Kinsey?
From 8 to 15 is -7.
Yep.
And then the next one's -9.
Yep, -9. So because this last one, it's not the -7 like the others, so this is not linear. So if we were to graph this, it would be straight, and then all of a sudden it would get like really steep or really shallow. So this one would be steeper, actually. All right, and then the second one, pick somebody random again. Using that one. Moses, how about the second one?
Yes.
Because, what do they change by each time?
3.
Yep. So yes, this one's linear because they change by 3 each time. Okay. That's just kind of the first basic part, and the next one are going to be our more intense stuff. So we are going to be looking at this figure right here. I guess it's a diagram, and I want to know what is the relationship between the number of rectangles and the perimeter that all these rectangles form. You guys remember what perimeter is, real quick? What?
Inside
No, that's area.
Area of the
the around the.
Yeah.
around.
It's the outside. Perimeter
Yeah.
is the outside. Perimeter is the amount outside. So we just add up all the outside parts. So, it wants to know what's the relationship between the number of rectangles and the perimeter of the figure they form. And we're going to represent this using a table. We're actually not really going to use words because we're just going to say it, so you can cross that out. I copied this out of the book and they want you to use words, but that's not as exciting to me, so we're just going to do a table, an equation, and a graph. So we're going to start with a table here. So what I'm going to do is I'm going to make the number of rectangles be in my first column here, and I'm going to make my perimeter here in the second column. So I'm going to get my numbers from my diagram here. So when I have my number of rectangles, when I have one rectangle, I want to know what's my perimeter in that one. So when I look at this, perimeter is the amount outside. And if this is a rectangle, if this top piece is 1, what's the bottom piece? 1. If the left is 6, the right? Yeah. So my perimeter, I just need to add up the outside. 6 and 6 is 12, 13, 14. My perimeter is 14. Okay, I'm going to keep going through and I'm going to keep filling out a table. Now when I have 2 rectangles, I need to find my perimeter. And remember, perimeter is the amount outside. So we kind of already said if the left is 6, the right is 6. But is this little inside piece? It's not part of the perimeter, so I'm not going to add that in. I'm only adding in the outsides. So all I care about is this part right around here. I don't care about that middle piece. And then I'm going to have to look on this part right here. If this top piece is 1, so is the bottom piece. If that top piece is 1, so is the bottom piece. So my new perimeter now is 6 and 6 is 12, 13, 14, 15, 16. My new perimeter is 16. And I'm going to keep going through. I still have 2 more parts of my table. when I have 3 rectangles now, when I have 3 rectangles, I'm going to count my perimeter again. So 6 and 6 is 12, 13, 14, 15, 16, 17, 18. Pretty easy. I bet you guys can see the pattern already, or even on the last one. And then my last one, when I have 4 rectangles, squeeze it in right here, I'm going to do my perimeter 6, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Oh yeah.
Pretty easy so far, I hope. You guys got it. So, what we did is we just represented the relationship using a table. We just made this into a table. We're also going to make an equation out of this, and it's going to be kind of basic. We're not going to use like variables and stuff. We're just going to use some words. So let's take a look at this. What's my how much is my perimeter changing by each time? It's adding 2, right? So I need to come up with an equation or a way I can represent this. Using some kind of a basic equation here. So if I'm going by 2 each time I add a rectangle, right? I'm going to say my perimeter, because I'm going to make the equation and say if my perimeter is going to equal something. It's got to equal something. And when I look at this, every time I add a rectangle, I am adding 2 to my perimeter. So I'm going to say my perimeter is going to equal 2 times the number of rectangles but that doesn't quite work. I have to add in something else, because when I have 2 rectangles, if I do 2 rectangles, 2 times that is 4, right? That didn't quite work. If I had 1 rectangle, where did my perimeter start with? What was my, when I had 1 rectangle, what was my perimeter? 14, right? So, I'm going to have to start at 14 and then add 2 times the number of rectangles. So my perimeter is going to equal 2 times the number of rectangles plus 14. Because it's changing by 2 times the number of rectangles, but I have to start here at 14 before I can start changing. So I started at 14, then I went up by 2. So now, if I look at my equation here, when I have 2 rectangles, 2 times 2 is 4, plus 14, nope, whoops, nope, I missed that one up. Yeah. Because 2 times 2 is 4, plus 14 is not 16, 18. So really, let me back up. I mean, I was testing you the whole time and nobody caught it. I totally didn't mess one up. Totally. Alright, let me back up again. Yeah. Alright, so I am going 2 times the number of rectangles, right? If I start at 14, like I said before, if I start with 1 rectangle, 2 times 1 is 2, plus 14 is 16. That didn't work, right? What do I need to start with if I want it to be 14 for the total? 14 plus the number of rectangles. That number 14 doesn't work, right? Because if I have 1 rectangle, I am... Right, let me think of a better way to explain this. Yeah, we'd have to start with 12, not 14. I'm trying to think of a better way to explain this, but now that I got it wrong, I'm drawing a blank. Oh well. I'm going to blame Greg. Because I can. I'm just messing with you guys. Yeah, that was my bad. Yeah, we'll get on the next one we deal. On the next one we'll do a little better job of that. That was my bad.
I'm very confused.
Yeah, I know. I'm sorry.
Put that one on your YouTube channel.
I'm gonna have to edit this video. All right, we're gonna do another one. I'll do a better job of explaining that. But we are gonna keep going on this. So we did a table. We did an equation. It's kind of a crappy equation, but I did a bad job explaining, but we got it. And we're also going to graph it. And what we're going to do is we are going to graph our table right here. So give me 1 second, because I am going to, I can't go back and forth and look at this while I make my table, so give me a second to copy it. So that way I can see it as I graph it. paste this in right here. There you go. All right. Now I can see what I'm graphing here. So we are going to graph these, but let's look at this a little bit before we graph them. I've got this table here. Whenever you have a table, the left side or the top side, sometimes our tables will go this way, like this, and you'll have numbers going left and right instead. The left or the top is always our X. The right side or the bottom is always Y. It's always like that. So left is always X, right is always Y. So I'm going to have to graph the point 1, 14, 2, 16, 3, 18, 4, 20. But before we start to graph this, do I want to go all the way up to 14? Or, I guess, do I want to count all the way up to 20 when I do these?
No.
No, we don't have 20 lines there.
Just
So,
go twos.
we're going to go by 2s on my Y's. My biggest Y is 20, so I'm going to go by 2s. So I'm going to make this first line right here, 2, and then 4, and then 6, 8, 10, 12, 14, 16, 18, 20. And now that I've done this, I can start graphing my points. I could do the same thing with x's, but my biggest x is 4, so I'm just going to go by 1s there. If you're going by 1s, you don't need to write numbers, but if you're going by like 2s, you have to write the numbers there so people know. So on my earlier graphs, that kind of first one we did, they were really small numbers. We went by 1s. I didn't need to. So I'm going to go through, and I'm going to do the point 1, 14. I'm going to go over 1, new color, over 1 to 14, and then I have 2, 16, 3, 18, and 4, 20. And we are almost done. Because we are graphing this, and we're graphing linear functions, we can't leave it as dots. We got to connect it. We got to connect the dots, because linear functions are lines. So right now, this isn't a line yet. It's just a bunch of dots. So I'm going to make it a line just by connecting my dots and going a little bit farther out, and then I'm going to put some arrows on the end to show that it's my line and it keeps going. If you don't have the arrows, it's technically wrong, because then if you don't have arrows, it means your line stops. This line doesn't stop. We're just only graphing a little piece. That makes sense? Keep your headphone on, Fredo. Last warning, you're taking them. Take them out, keep them out. Thank you. Alright, so this is going to be most of our lesson. We're going to do this again on a new type. This time I won't mess up the equation part quite so much. Actually, before I go, did everybody have this down? Is anybody still working on it? Still working on it? Okay, I'll give you time. Remember, if I go too fast, just let me know. Still working, Ashley? Yeah. Okay. All right. So, same type of thing we're going to be doing. This time, we're going to look at this table over here on the right, and it shows the relationship between the number of photos, X, you take, and the amount of memory, Y, in megabytes, left on your camera's memory chip. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph. And we're actually not going to do words, because we're going to just do an equation. So, we're going to make we're actually going to make a table, because that's going to help us graph it, and then we're going to do an equation, and then we're going to graph it. So let's go through, let's make our table. Even though this one doesn't say to make a table, we need it to graph. Actually, no, we don't need it to graph. We have the table. What am I doing? Play Greg. Gonna play Greg again. Alright, we already have the table right there. So we're just going to make an equation, and we're going to graph it. So let's look at our table. When we have 0 photos, we have 512 memory left. 1 photo, 509. After we take 2 photos, we got 506. And after 3 photos, we have 503. So how much is this changing by each time? It's going down by 3, right? Minus 3, minus 3, minus 3. All right, so let's make an equation for it. And we're going to talk about the memory, what our memory is going to equal. All right, it's going to equal something. So, let me, for the equation, I think this is a better way for me to explain it. When I make these, I have to start somewhere. My memory has to start somewhere. And when I start, it's before anything has changed. So in this case, my memory is before I take any pictures. Before I've taken any pictures, how much memory is there? 512, right? That is where I'm going to start. And how much is this going down by each time I take a picture?
Negative 3.
It's going down by 3. So I'm starting at 512, and I'm going to go down by 3 for each picture I take. So my amount of memory is going to equal where I started minus 3 per picture, or 3 times the number of pictures.
Wouldn't that just be 3x?
It would be, but we're going slower. And we're going to lead up to that, Moses. Slow down, Moses. Slow down. So, if we were going to make this into an equation with an x and y, it would be y equals 512 minus 3x. But we're going to start off a little easier and just start kind of writing it with words instead of variables. So, I started at 512, and then I minus 3 times my number of pictures. So when you make the equation, it's always going to be where you start, and then plus or minus how much you change. So it's always going to be where you start and then plus or minus how much you change. I started at 512 and then I'm minusing 3 times the number of pictures. And we're going to graph it next. And just like before, I'm going to copy this real quick so that way I can actually look at it while I make my graph. Everybody have this down though? Still working on it? You got it, Lily? Got it, Ashlyn? Okay. Got it?
Yeah.
Okay. So we're going to graph this, and this one I don't think you guys have done before. I don't think you guys have seen this piece before. So we are going to graph this table right here. And let's look, my x's, I'm going from 0 to 3. Do I need to make my x's go by anything other than 1? No. So the y's though are where it's a little more interesting. What's my biggest y?
512.
What's my smallest y?
507.
Aren't those really close together? They're pretty close, right? I mean, they're only like 9 apart. But those are really, really big. So, do we want to count up 503? No. We could make our y's go by something like 100s or maybe 50s. But if I do that, these are really close together, right? My graph's going to be really tiny and it's going to be hard to make. So we're going to do a little bit of a shortcut. What we're going to do is we are going to skip some numbers, and I'm actually going to start at 503. But when I do this, I can't just put like 503 right here. I can't put 503 right there and start my graph like that. I have to show that I'm skipping numbers. So what we're going to do is right here on my origin, I'm going to draw kind of a squiggly line thing like that. And what this means is that we are skipping numbers. It means we skipped numbers. So I'm going to skip basically 502 numbers, and I'm going to start here at 503. and which is fine as long as you have the little squiggly line right there. If you don't have it, it's wrong technically. But if you have it in, you're good. It's kind of a weird nitpicky thing. So I'm going to start at 503 now, and I'm really not going very high, so I'm just going to go by ones. So 503, 504, 505, 506, 507, 508, 509, 510, 511, 512. Just to bug you, Moses. Now that I've got this, now I can graph my points like normal. So I have 0, 5, 12. I'm going left and right 0. I'm going to go all the way up to 512 and put my dot. I have 1, 509, 2, 506, 3, 503. We've done most of the work, but we're not quite done because we have to actually connect our dots and we got to put our arrows on them. So I'm going to go through and connect my dots with my super nice line. Oh yeah, that's almost great. And after we do that, now we're done. Alright, how are you guys feeling about this stuff? Do you want to do an in-class problem or do you want to skip to the exit ticket? Skip to the exit ticket? Exit ticket?
Yeah.
Sure.
When are we ever going to have to use this in life?
So you're ever in like a business and you're making your own graph or something? Showing how much like profit or loss you've had? A lot of different times. Alright, so to save a little bit of time, we are going to skip this and we are going to go to your exit ticket. Go to your exit ticket. So, on your exit ticket, you're going to make a table. You're going to make an equation. And also to save some time, we're just going to do table and an equation. Don't graph it. So, do your exit ticket, answer it in Socrative here in just a minute. Let me put it on here. Basically, yeah, just like the rectangle one.
So, do you want
What?
why didn't it just be?
Man. So, remember perimeter though. And it's a square, right?
Yes.
So, square, every side is 2.
Oh.
So, when you have one rectangle,
Okay.
your perimeter will be 2, 4, 6, 8,